Today I'm going to talk about how you can solve equations with variables on both sides. Let's just dive right into this first example. When you solve equations with variables on both sides, really the goal is to get your variables all on one side and your constants all on the other side. So with this example, you'll notice that we already have a variable term on the right-hand side all by itself, the negative 9x. So what we can do now is move this negative 4x, the minus 4x, we want to move that over with the other x variable. We want to get all the x variables on one side, and then the constant 10 will stay on the left side and actually be by itself as well. So when we're moving terms around, you want to use inverse operations, just as if you were moving a constant to the other side. So in this case, we have a minus 4x. The 4x is negative. It's being subtracted away from the 10. So we want to use the inverse operation, in this case, plus. Since it's being subtracted away, or also because it's negative, we want to add that same term. We're going to add 4x to both sides. And when we do that on the left-hand side, the minus 4x and the plus 4x, those undo each other and they cancel out. That's just going to leave us with 10 on the left-hand side. Now, how do we add the negative 9x and the plus 4x together? Just as if you were combining like terms, because that's what they are. So we want to combine the coefficients and keep the x variable along with them. So we have negative 9 plus 4, it will get us negative 5, and the x variable just stays the same. Now we just have a one-step equation. A lot of the times when you get your constant on one side and all your variable terms on the other side, and you combine all your like terms, most of the time you will get down to a one-step equation. And in this case, we just have to get rid of that negative 5 out front of the x. And to do that, since the negative 5 is being multiplied with the x, we want to divide both sides by negative 5. The negative 5's on the right-hand side, those are going to cancel out. And on the left-hand side, you have 10 divided by negative 5, which will get us a negative 2. If you want to rewrite it so that the x, the variable, is on the left side, you can do that. I know that's standard, you do see that a lot, but either way you write it is completely fine. Now that we have the variable by itself and we've solved the equation, we can go ahead and check our answer to make sure we did it right. And to do that, we want to rewrite the original equation. You always want to rewrite the original equation because we want to make sure we didn't do anything to it yet. And since we said x was equal to negative 2, anywhere we see an x, we want to replace it with that negative 2. And we do want to make sure we put it in parentheses because the negative 4 right here and that negative 2 and the negative 4 and the x, those are being multiplied together. So we want to make sure that that's not getting confused in any way, thinking that you're subtracting the 2 away. So now we can go ahead and simplify. You can simplify one side at a time or both at the same time. It's really kind of up to you. On the left-hand side, I'm going to multiply the negative 4 and the negative 2 together. That's going to get a positive 8. I'm also going to multiply the negative 9 and the negative 2 together. That's going to get us a positive 18. And to finish simplifying, 10 plus 8 gets us 18. And yes, 18 is equal to 18, so that means that we solved the equation correctly. X is equal to negative 2. So now let's take a look at this example. It may look a little bit more complicated because not only do we have variables on both sides, but we have constants on both sides. And that's okay. We want to put all the variable terms on one side and all the constant terms on the other side. And to do that, there actually are a few ways. You may not do it the exact same way as somebody else did it, and that's okay. It's really the end goal is just to make sure that you're getting the same answer as somebody else who may have done it differently. What I like to do is try and keep the variable term positive. Honestly, it doesn't matter. It's just kind of my preference. So to me, to get all the variables on one side, keeping them positive, I would subtract this 2p from both sides. And we're subtracting it because the 2p is positive and it's being added to the 12. So to get rid of a positive 2p, you want to subtract away a 2p from both sides. Now you'll notice that when we do 5 minus 2, that'll get a positive variable there. And again, you don't have to do it this way. You could have subtracted a 5p from both sides to get the variable all on one side. And when you do that, you'll notice you'll just get a negative 3p, but the answer will still come out to be the same at the end, no matter where you start adding or subtracting things. Now this is just a two-step equation, so we can actually go ahead and add a 9 to both sides. Again, we want variable terms on one side, constant terms on the other side. So when we do that, we get 3p equals 21. And then we can go ahead, and since this is really 3 times p, we can divide both sides by 3, and we'll get p equals 7. So again, you could have gone a different way about this. I'm actually just going to rewrite this over here. We're not going to check it yet. And I'm just going to rewrite it and actually solve it a different way and show you can still get the same answer. So instead of subtracting that 2p from both sides, let's maybe subtract this 5p from both sides. We'll have a negative 9 on the left-hand side, and 2 minus 5 will get us negative 3p. So it now looks a little bit different than the first time we did it, but that's okay. We'll just keep going. So we can subtract a 12 from both sides, and we'll get negative 21 equals negative 3p. This is kind of where it looks similar, but the signs are now different. So now everything is negative, but when you divide by that negative 3, you still get p is equal to 7. So notice if you start it out a different way, you will still get the same answer in the end. So now I'm just going to actually clear this side so we can actually go ahead and check to make sure that that negative 7 is actually the correct answer. You don't always have to do this, but I like to do it just to make sure that I am getting the correct answer in the end. So whenever we check again, we want to just copy down the original problem, and then anywhere we see a p, we're going to plug in 7 because that was the answer that we found. And then we can go ahead and start to simplify. So we can do 5 times 7, which is 35. And on the right-hand side, this should be a plus, sorry. On the right-hand side, we're going to do 2 times 7, which is 14. Now we can go ahead, do our last step on either side. 35 minus 9 is going to get us a 26. And 14 plus 12 will also get us 26. So since 26 is equal to 26, it's a true statement. That does mean that p equals 7 was the correct answer to this equation. And to kind of sum up what we did, when you have variables on both sides of your equations, you always want to get your variable terms on one side and your constant terms on the other side. So pick a side to move your variable terms to, and then move your constant terms to the other side. And that's how you solve equations with variables on both sides.